Press the bell icon on the YouTube app and never miss another update.
Next, differentiability in intervals. Differentiability in open interval of a comma b. Open interval of a comma b means suppose on the real line it is a, b, b. Open interval means except b, here except a. It is taking infinite numbers between a and b. If f of x, for example, the given function y is equal to f of x. If f of x is differentiable at each and every point of open interval of a comma b, then it is called differentiable function in open interval of a comma b. Means if f of x is differentiable in or at each and every point in open interval of a comma b, then f is said to be differentiable in open interval of a comma b, just like that. Next, in closed interval of a comma b. For closed interval of a comma b, the differentiability in closed interval of a comma b, three conditions are there. Namely, number one, f of x must be differentiable in first open interval of a comma b. Next, second point, f dash of a plus exists. That is, f dash of a plus means what? Limit h tends to 0, f of a plus h minus f of a divided by h exists. It must be exists. Number 3 point b, it's preceding, means f dash of b minus not plus exist. That is, limit h tends to 0, f of b minus h minus f of b divided by minus h. It is what actually right hand derivative at x equal to a. It is what left hand derivative at x equals to b. So subject to three conditions, we can say that f of x is differentiable in closed interval of a comma b. Later, one trivial proof, if f comma, next point, f comma g are differentiable functions, then number one, f of x plus g of x and f of x minus g of x. Number 2, f into g of x. Number 3, f divided by g, means g of x, of course, it is not equal to 0 for all x belongs for all x. So, whenever f comma g are differentiable function, then f of x plus g of x is also a differentiable function, and f of x minus g of x is also a differentiable function. F of x into g of x is also a differentiable function, and f of x divided by g of x is also differentiable function, but subject to the condition g of x is not equal to 0. Later d by dx of something k into f of x is equal to k into d by dx of f of x. Okay, simply it is denoted by k into, it is what? Simply f dash of x. Next, very important formula, d by dx of u into v. U means what? U is something function of x. V is what? V is also something function of x. So that is equal to simply u dash v plus u v dash. Full form, u dash means that d by dx of u of x into v of x, second function, plus here u means u of x into d by dx of v of x, or in other words we can take d by dx of f of x into z of x is equal to d by dx of f of x into something z of x plus f of x into d by dx of g of x, or else simply f dash of x into z of x plus f of x into z dash of x. Dash means d by dx derivative. Next, another important formula, that is quotient formula, u by v, that is equal to, first habituate to write denominator. Denominator is v square. In numerator start with v, under letter u dash, but minus u v dash. That is, v means what? V of x. Dash means what? D by dx of ux minus u of x into dash means what? D by dx of v of x divided by v of x whole square. Next, another formula. For example, here we discussed for two functions u into v. For example, d by dx of three functions u, v, w, three functions. It is matter of two functions, but it is matter of three functions. First, I will tell the easy remembrance. Write u, v, w. How many functions are there? Three functions are there. Write three sums just like that. U, v, w, u, v, w. Latter, order of preference, alphabetical order. In alphabet, it is first u comes, latter v, latter w, just like that. So first u, for first u put a dash. Latter in second sum put dash for v. Latter dash for w. Means what? D by dx of first function into second function same, third function same, plus first function same, d by dx of second function into same, third function same, plus first function same, second function same, next d by dx of third function. So this is d by dx of u, v, w. Next, some standard results, namely d by dx of first constant, that is equal to 0. For example, d by dx of log 7, that is equal to what? Actually, it is d by dx of means differentiation of log 7 with respect to x. But there is no x. That's why this is a constant. This is the constant with respect to x. So therefore, its value is 0. Indirectly, there is no x when they are differentiating with respect to x, like that. Next, second formula. d by dx of x to the power of n. d by dx of x to the power of n means what? Derivative of x to the power of n with respect to x. Of course, x is called independent variable. Here, x is called independent variable. Once again, dy by already we said f dash of x different notations, dy by dx, y suffix 1, y dash, dy by dx of f of x, f dash. All these are the notations for first derivative of f of x with respect to x. Already I said in the previous episode. Okay, f dash of x means what? Derivative of y with respect to x. X here, x is called independent variable and y is called dependent variable. Y is called dependent variable, x is called independent variable. Actually, strictly we have to read it as d by dx of y, just like that, but not dy by dx. If you are reading dy by dx, it goes to ratio, means a is to b, but it is not ratio of, it is not ratio of dy and dx, just like that. Okay, this is one beautiful concept. Okay, so d by dx of x to the power of n, formula n into x to the power of n minus 1. Some examples. First, d by dx of x. X means what? X power 1. So instead of n, 1 is there. So just to put n equal to 1. 1 into x power 1 minus 1. So 1 into x power 0. So 1 into any finite value whole power 0 is 1, that is equal to 1. Therefore, d by dx of x equal to 1. So you can treating as a formula also. So main basic formula d by dx of x to the power of n. Next, second example, d by dx of x square. So d by dx of x square. Here compare with d by dx of x to the power of n. Instead of n, what is there? 2. So put n equal to 2. So it is 2 into x to the power of 2 minus 1. So 2 into x to the power of 1. So 2x. So it is better to this small question as a formula. It is 2x. D by dx of x square is equal to 2x. Later, d by dx of root x means root means what? Whole to the power of, it is nothing but x to the power of 1 by 2, whole to the power of 1 by 2 means instead of n, what is there? Half. So half into x to the power of half minus 1. So half into x to the power of minus 1 by 2. So it is nothing but 1 by 2 into x to the power of plus 1 by 2 according to the laws of indices. So that is equal to 1 by 2 into root x. So therefore d by dx of root x equal to 1 by 2 root x. So it is better to remember as a formula. D by dx of root x equal to 1 by 2 root x. D by dx of x square equal to 2x. D by dx of x equal to 1. D by dx of x to the power of n equal to n into x power n minus 1. Later, d by dx of 1 by x to the power of n. 1 by x to the power of n. Actually, to be frank, it is not new formula. It can be written as x power minus n. So compare, instead of n, just you write minus n like that. So n means minus n into x power n. N means minus n, minus 1. So that is equal minus n x power minus of n plus 1. So that is equal minus n divided by x power n plus 1. So therefore d by dx of 1 by x power n is equal to minus n by x to the power of n plus 1. So we can take one beautiful example for the application of this formula 1 by x square is equal to instead of n 2 is there, that's why it is minus 2 divided by x power 2 plus 1 means 3. So similarly we can make the number of examples. So it is also one of the most important and simple formula d by dx of 1 by x power n equal to minus n divided by x to the power of n plus 1. Later d by dx of e power x, same, e power x. These are the standard results, standard formulae. Actually these are derived from the first principle of derivatives, means f dash of x equal to limit h tends to 0 f of x plus h minus f of x divided by h. From that formula we derived all the results like that, d by dx of, out of which this is another formula, d by dx of e power x equal to e power x. Whichever I put in the box, you must treating as a formula and by heart and practice well. Next, d by dx of exponential, another exponential function a power x into log a, of course the natural logarithm base e. This is another formula. We can use this formula or apply for this kind of, for example 2 power x is what, 3 power x is what, 4 power x is what, and another critical formula d by dx of 2 power minus x. Actually it can be written as d by dx of, it is 2 power minus 1 whole power x. Of course it is d by dx of 2 power minus 1 means 1 by 2 whole power x. Very neatly, clearly you can compare with a power x, whereas a is equal to here 1 by 2. So formula a power x means 1 by 2 1 by 2 whole power x into log base e 1 by 2. So it is nothing but 2 power minus x into minus log 2 to the base e. This is the answer, d by dx of 2 power minus x. The next, log x, d by dx of log x, I mean to the base e. This is one of the important formula. D by dx of one of the important formula, d by dx of log x base e is equal to simply 1 by x. Now our question is, sir, if the base is different, means log to the base something a, it is different from e, then also 1 by x? No, it is not at all equals to 1 by x. How? Let us see. D by dx of log x to the base a. Actually d by dx is also an operator, just like LT, limit x tends to a, just like that. Log x, so it can be written as a base e base e x. We can write according to the laws of logarithms, we can write like that. Log x means I put the same base, later I introduce e. Remember this e same, so we can write log x base a can be written as log base a e into log x base e. Actually instead of e you can write any number, but we are discussing and we did know log x to the base e derivative is 1 by x. That's why I wish to express this in terms of e only. So anyhow log e base a is the pure constant. Already I said one formula, d by dx of something k into f of x is equal to k into d by dx of f of x. So according to that formula, k means here log e base a into d by dx log x base e. Now we are getting well-known formula. So in the form of, it is in the form of well-known formula, log e base a, very clearly it is 1 by x. So it can be written as, x is as usual, it is 1 by log a to the base e. So therefore d by dx of log x to the base a is not equal to 1 by x, but it is 1 by x into log a to the base e. This is one formula. For example, d by dx of log x base 2, it is not equal to 1 by x, but it is equal to 1 by x into log 2 base e, log 2 base e. This is all about derivative of log x. Next, exponential function, constant, some algebraics, next exponential over logarithm over, next trigonometric function. D by dx of sine x is equal to cos x. You have to make a notes and by heart and practice well. Next, d by dx of cos x equal to minus sine x. Next, d by dx of tan x equal to secant square x. Next, d by dx of cot x equal to minus cosecant square x. Next, d by dx of secant x, d by dx of secant x equal to secant x into tan x. Observe plus minus plus minus plus, just like that. D by dx of cosecant x minus cosecant x into cot x. So over. Next, derivative of composite function. Derivative of composite function. Actually, we are considering f circle g of x function. It can be written as f of g of x. So, according to definition, g of x are simply the function, means if g is differentiable at x. If g is differentiable at x equal to x and f is differentiable at g of x, then only f circle g of x is differentiable. Similarly, how can we define for g circle f of x? Actually, g circle f of x means g of, it can be written as g of f of x. So, for which f must be differentiable at x and z must be differentiable at f of x, then only g of f of x is differentiable. Okay, next, f circle this one g of x. If f circle g of x is differentiable, then its derivative will be, actually it is f of g of x whole dash stands for the derivative, first derivative, that is equal to, it can be f dash of g of x into z dash of x. It is the definition. Similarly, g circle f of x dash derivative, that is equal to it is nothing but g of f of x all dash. It is z dash of f of x into f dash of x. F dash of x. Okay. This is the derivative of a composite function.